Our next presenter is Erich Beregszaszy, and he is a graduate from the University of Michigan in Dearborn, and he received his master's degree in science education from Michigan State University. He's a third-year teacher in chemistry and physics at Troy-Athens High School and a content area leader in physics, responsible for creating new curriculum based on the Michigan science standards. Erich was a science literacy innovation project member through Oakland schools and is trained in modeling in chemistry and in cultures of thinking. Tonight he's going to talk to us about the change for students away from spoon-fed information with quick and easy solutions to experiences followed by drawing conclusions. So erasing students into inquiry. Or excuse me, I misread that, didn't I? He needs to erase those students. All right, well, yeah. So easing students into inquiry. Yeah. Thank you, Erich Beregszaszy.
Sometimes I want to erase students. Anyway, no. Hi, my name is Erich, and I teach at Athens High School. And to kind of pile on to our last presenter, I did modeling this summer in chemistry. And so some of the things that she discussed and she talked about, you'll hopefully see in my presentation. And when you do modeling or inquiry-based teaching, it opens up a particular can of worms that I've noticed in my long 3-year teaching career at Athens High School. And I'm going to start off with a picture here to sort of set the tone. I'll let you enjoy that for a second, appreciate that, and maybe connect it to something that actually may happen in your real life. And when I see this picture, I think about my Chemistry 1 students that I currently have in the classroom right now, and I think about how when we do a lab, when we do an activity, I will walk around the lab, and my students will naturally engage me in active questioning. Like, Mr. Bear, that's what they call me, because Beregszaszy is obviously awful. So, Mr. Bear, is this right? Is this the right answer? Does this look good? Is this the correct way of doing it? Where'd you get your sweater? Banana Republic. Anyway, and it's difficult for students because science is kind of a two-sided coin. On one side, we want our students to do all this inquiry-based learning where they're discovering the way the world works around them. And on the other hand, it's really sort of a rigid thing. F always equals ma. Gravity is always negative 9.81 meters per second squared. When you name copper sulfate, you always need the Roman numerals 2. I'm not IUPAC. I don't make the rules. So the question is, how do we get our students to be more comfortable with the bottom part of this picture, the struggles and the chaos that inquiry-based education and NGSS has to offer? So the first thing I had to do is I had to change the way my brain works. When I first started teaching, I had this idea that when I do a lab with my students, they're going to do the lab, it's going to go well, they're going to get data, they're going to turn in some kind of packet, and I'm going to grade it, and we all hold hands and sing Kumbaya and be happy. The problem with that is, it didn't work that way. As I kept doing labs with my students, things got kind of messy. And so as I started thinking about these things with my colleagues at Athens High School, we started realizing that failure is actually a really good thing. And that might be the whole theme to my presentation. Other than erasing students, failure is okay. Maybe erasing them would be a failure, I don't know. But the idea here is that even bad data can be good data with the right intention. So if I take the time to think about my labs, what I want in terms of content, maybe I want them to get the law of conservation of mass. Maybe I want them to get that a penny is 2.5% copper. But maybe it's some kind of science practice. Maybe I want them to be able to write a table or come up with a conclusion or share their data. And if I balance that and sort of prepare for failure, good things will naturally happen. I've also made some changes to my practice. This year at the beginning of the school year, I was very upfront with my parents. I said, listen, your students are going to do this inquiry-based style of education. They are going to do what real scientists do, and they will have to draw conclusions. It's kind of scary, it's kind of messy, they're going to complain a lot, more than they already do. And the parents, rather, were really excited by this. Like, wow, my kid's gonna have to use their brain to do science, like, awesome. And from doing that, I haven't gotten any parent concerns this year. And of course, the students have no choice. They're there for it. So I did that at the beginning of the year. The second thing I've had to do is really pay attention to how I scaffold things. The last thing you want to do is blow their minds on the first day of school and lose them for the rest of the year. So maybe the first lab, we just work on communicating information. We're going to present to each other, and we're not going to be afraid to look each other in the eyes and be wrong. That's a thing we have to work on. Maybe the second lab is designing an experiment. So whatever that is, I scaffold it so that by the end of the year in June, they can take on some pretty massive projects on their own and be comfortable with it. I also do a lot of celebration when it comes to failure. You can't be afraid to celebrate some weird stuff, especially at the beginning of the year. And again, that's going to depend on what lab or activity you're doing. And I also make sure I prepare a little bit better. I've noticed a lot of times when students are doing activities and coming up with their own lesson plans or lesson designs, that there's a little bit of a struggle there. And things go wrong and they fail, and that's good. I'm the champion of failure. So the problem with that is if I don't anticipate what's going to happen a little bit better, I can't redirect them. So if I know a particular lab is going to be a struggle for students, I go out of my way to try and predict what that failure is going to be so I can kind of re-guide them in the right direction. So this is an activity. This is actually an activity I took from modeling, so another shout out to them. And basically what happens here is students are responsible for explaining some kind of phenomena. And that phenomena is an exploding paint can. So we fill the paint can with some methane gas. There's a hole at the top, and we light it. You can see that there's a pretty high flame right there. Blast shield just for dramatic effect. And basically, we ask the students on the first or second day of school to draw a particle diagram and explain what happened. And they're terrible. But they don't know any chemistry yet, and it's okay. So what do? I grade it with a rubric. And they all get like 0 out of 10. And it goes in the grade book. But we have developed a grade book and a grading system that allows us to actually have a category called for feedback only. And this grade goes in there so parents and students can actually see the students' grades, get feedback, but it doesn't actually impact their overall grade in the class. What I've noticed with this is it's huge because students don't want to hurt their grade. They're very grade conscientious in Troy. So when we do that, they have an opportunity to get feedback and improve without necessarily tanking their grade to pieces. So then what do? Well, we do Unit 1 of chemistry. We talk about density, and we talk about mixtures, and we talk about chemical reactions. And 3 weeks later, we come back to it again. And this time, I have them do it in small groups. And they get some data, like flammability of gas data for methane and oxygen and nitrogen. And in their small groups, they meet with other small groups and other small groups, and eventually the whole class comes up with some kind of consensus, and they can do it again. And you can see here, this is the same student's paper 3 weeks apart. So even though the one on the right or the one in the middle isn't perfect yet, it's a heck of a lot better. And together, they've gone from a complete lack of understanding to something really beautiful. And in order to do that, they had to use microscopic particles to describe something bigger. They had to use data. They had to present. They had to talk to each other. They had to do all these great science things that are part of NGSS and part of the Michigan Science Standards to get through this bottom part. The oh my forkin' goodness, what is happening to us chaos. And the thing is, some of my students will struggle. I shouldn't say never. Never is a strong word. But they'll struggle down there. And it'll take them a long time to get to that eureka moment. But in this case, they got to it together. And I never had to stand up there and say, this is the right answer. I said so. And because I say so, everything I say is true. All hail Mr. Bear. He is amazing. Yay. I never had to do that. even though that would feel good. It would be great for my self-esteem. Maybe I should do that. No, probably a bad idea. So they were able to come up with this together, and it was an enriching experience for them. And that's what really we're all about. And this is my last slide. There's obviously my email address in case you ever want to like late night email about all your science hopes and dreams in the world. There's also a little QR code to my website. And I wanted to include this picture up there because as much as I consider the importance of standards and the way I teach and the way I grade and all this stuff, it all comes back to them and the fun that we get to have together. And I know in 5-10 years, they're not going to be like, remember that time Mr. Bear had us do that inquiry activity? Boy, his lesson plans, wow. They're not going to say that. I would love for them to say that. I can't even say that about my high school teachers, and they were all phenomenal. But they're going to remember the fun we got to have together, and that's sort of what it's all about. So, thank you.